Okay, in this video we're going to have a look at what is meant by a displacement reaction. Before we do that, it's useful just to have a look again at the reactivity series, which is in your books. And you see the reactivity series is a list of elements, most of which are metals with the exception of carbon and hydrogen, starting with the most reactive at the top and working our way down to the least reactive at the bottom. And this list has been put together based on observations of reactions of these elements, as you saw in one of the previous sessions with water, and we can then use the observations to decide which of these elements is the most reactive, working our way down the list. We're going to use this idea to make predictions and use these ideas to understand what is meant by a displacement reaction. Okay, so first of all, it would be useful just to define a displacement reaction. A displacement reaction is defined in this way. It's when a more reactive element displaces, pushes out a less reactive element from its compound. Probably the best way to illustrate this is to use an example. So let me just put this in front of you. This is taken from your books. If you find this in your books, you can complete this in there as well. And you can see at the top it says what is meant by displacement reaction. We've just defined that. And then here's our example. Okay, we have got copper oxide reacting with magnesium. So here's my compound. This is the element. If I come back to here, I can see that magnesium is more reactive than copper. So magnesium is higher up in the reactivity series. It is more reactive than copper. So in this reaction, the magnesium, being more reactive, is going to displace, push out the copper from the copper oxide compound. And that will lead to the formation of magnesium oxide, the brand new compound that's been formed, and the copper has been pushed out from the compound or displaced. Okay, in terms of formulas for this, copper oxide is CuO, and we've got magnesium reacting with it. This will make magnesium oxide and we get our copper displaced. It's already balanced, so I don't need to add any other numbers to make that work. If we have a look at the alternative to this, so if we had the copper with the magnesium oxide, then this reaction wouldn't work. Why not? Because the copper is less reactive, the magnesium is more reactive. The magnesium's already got the oxygen, it's already a compound with the oxygen. Therefore, the copper cannot displace, push out the magnesium from this compound. So we have a choice of just saying there's no reaction, or sometimes you might see it written where these are just written exactly the same this side, showing that there's been no change. In your notes, underneath each of these two reactions, it's asking you to explain these so that you can understand why this reaction has worked and this reaction hasn't worked. Okay, in this little section of the video, what I'm going to talk to you about here is how we would actually do a displacement reaction. We're obviously not in a position to do these at the moment, so I'm going to get you to think about this theoretically. You've probably watched a video that illustrates one of these reactions. It illustrates the magnesium reacting with copper sulfate, and you can then see what happens. Okay, what I'm going to ask you to do is this. We're taking 4 compounds. We've got copper sulfate, magnesium sulfate, iron sulfate, and zinc sulfate. I'm reacting them with the elements, as you can see, copper, magnesium, iron, and zinc. and you would watch the reactions to look for signs of reaction taking place. The most common sign you see is a colour change during this reaction if a displacement reaction is occurring. If there's no reaction, no colour change, then the displacement reaction hasn't occurred. Okay, and from this type of grid, you would then work out which of these metals is the most reactive, which of these metals is the least reactive. What I'm going to do is do this in reverse a little bit. I'm going to tell you that this is the reactivity series for these 4 metals, so magnesium, zinc, iron and copper. And what I want you to do is any of the boxes underneath that are empty at the moment, I want you to make a decision if there would be a reaction or not. If there's reaction, give it a tick. If there's no reaction, put a cross in that box, okay? You'll notice that 4 of these boxes have got crosses in already. Why is that? Because copper sulfate and copper, there is no point doing that reaction. These are the 2 same metals. You will just, nothing will happen. Same with magnesium and magnesium sulfate. Magnesium, no point in doing it. So I want you to make a prediction. I'll show you the first one as an example so you understand what I'm asking you to do. So in this first one, we've got copper sulfate reacting with magnesium. I can see that magnesium is more reactive than copper. Therefore, I would expect the magnesium to react with the copper sulfate. So I'm going to put a tick in that box to show that that displacement reaction would take place. You do the rest. Pause the video here and then the answers will appear so that you can check your work against my answers. Okay, so pause the video. Okay, answers to the questions then. So magnesium will displace copper sulfate. Iron is also more reactive than copper, so that will displace it, and zinc is more reactive. So because copper is at the bottom, all 3 of these will react with the copper sulfate. Okay, magnesium sulfate. So copper will not displace the magnesium from the compound, so that would be no. Iron cannot do it, and zinc cannot do it. So this will not react because magnesium is at the top, most reactive, and therefore none of these metals are able to displace it. Iron sulfate, okay, copper is below iron, so that will, no reaction. Magnesium is above, so we'd expect a reaction, and zinc is above, so we'd expect to see a chemical reaction. Zinc sulfate, copper would be no. Magnesium is above, so magnesium would be yes. Iron would be no because it is below, okay? And you can see, just had you this in class, you'd have got these results without knowing this bit, but you can see that magnesium has reacted with all the sulfates, all the compounds, and therefore magnesium is the most reactive of these 4, okay? Zinc would be second because it's reacted with 2 of them. Iron would be third, it's reacted with 1, and copper would be bottom of the list because it hasn't reacted with any, okay? You should be able to answer question here about the 4 crosses. You should be able to answer, put them in the list of reactivity because we've done it backwards, but it's here. On the next page, it then asks you to do some observations between copper, sulfate and magnesium. Watch the video, get the observations there. This one, you could Google it yourself, find out what happens here, okay? And then we're going to do this bit in a separate video. So complete that bit up to there, and then we'll pick this back up. Okay, in this video, we're going to have a look at displacement reactions, but we're now going to try and look at it from the point of view of a redox reaction. If you remember, redox is all about understanding that oxidation is loss of electrons and reduction is gaining electrons. And we use this term, oil rig, to help us remember that oxidation is loss, reduction is gain. So let's apply those ideas to this work that we're going to look at here. So in your books, this is the page from your book. Bits of questions. It says describe what's meant by reduction, describe what's meant by oxidation, what's meant by redox. Remember, redox is reduction and oxidation happen at the same time. This is the bit I want though. It's going to give us an example to have a look at. Okay, so the example says that zinc is going to react with copper sulfate. If we get our reactivity series, we can see that zinc is more reactive than copper because copper is way down here. Okay, so I would expect this reaction to take place, and what I expect to happen is I would expect that the zinc would displace the copper. So I would get zinc sulfate forming as a compound, and I would get copper being displaced, pushed out over here because it's less reactive. In terms of formulas, I'm going to put those in. So copper sulfate is CuSO4. Remember, SO4 is a sulfate. Zinc sulfate, ZnSO4, and copper is Cu. Okay, I'm going to add a line into this now, and my line I'm going to add into this, I'm going to split these, particularly the two compounds, into their separate parts. So here I have got zinc, and then copper is a 2+ ion, and sulfate is SO4 2-. So the compound copper sulfate is made up from Cu 2+ and SO4 2- ions coming together. That's going to form zinc sulfate. Again, let's split this. So it's Zn 2+, and we get a sulfate SO4 2-, and then we get copper being displaced. So all I've done here again is split this compound into the ions that make it up. Now, if you have a look at this carefully, you will notice that some of these ions and elements have changed, some of them haven't changed. For example, if I look at zinc, zinc here is Zm, but on this side of the reaction, it has become Zn2+, it's become an ion. So that's changed, I'm okay there. Copper 2+, and then on this side it's become copper, so there's been a change. The sulfate is SO4 2-, and the sulfate here is SO4 2-, so the sulfate hasn't changed. So to help me, what I'm going to do is I'm going to get rid of anything that hasn't changed from the reactant side, the left-hand side, to the product side, the right-hand side. Okay, so sulfate has stayed the same, so I'm going to get rid of it, but everything else that we've just described has changed. Therefore, this equation becomes Zm plus Cu2+, I'm going to ignore the sulfates, goes to Zn2+ and Cu. Okay, that's what we've got. This is called the ionic equation because now our equation contains ions, charged particles. From this, I'm going to split this now into two parts. I'm going to look at the zinc as one part, I'm going to look at the copper as a separate part. Let's deal with copper first. So copper starts off as Cu2+, and it becomes Cu, okay? Let's ask ourselves, how does it do this in terms of electrons? If we go back to where we started at the beginning of our definition, that oxidation is losing electrons, reduction is gaining electrons. So how does this change? I've gone from a 2+ ion to an element with no charge. So to go from 2+ to something with no charge, I've got to add electrons to this side to make the 2+ become no charge. And I'm going to need to add 2. So I'm going to add 2 electrons here in order to make the copper metal form this side. Because I'm adding electrons, this reaction is reduction. Okay, let's look at the zinc. The zinc has gone from Zn, and then it's turned into Zn2+. How's it done this? Well, to go from something with no charge to something with a positive charge, you must lose negatives. You've got to release negatives. Okay, so I've got to lose negatives. Those negatives are being lost as the ion forms, so there they are getting lost. If this is being lost, oxidation is loss, so this is an oxidation reaction. And you can see that with these two reactions going at the same time, we have reduction and oxidation, therefore we have a redox reaction. So displacement reactions are examples of redox reactions. They involve the movement of electrons, the transfer of electrons during that reaction. Okay, in your notes we've started this off here. You can now transfer this information to here so that you can complete these notes and explain it. And then on the next page, page 32, there are some questions for you to try yourself. I'm going to suggest you have a go. I'm then going to put the answers in, and you can then check your answers against the answers that I've given to you. Okay, good luck everyone. Okay, so here we're going to go through one more of the examples of a displacement reaction that is redox. And you can see here we're going to take magnesium and we're going to react it with zinc sulfate. So pull in my reactivity series, and you can see that magnesium is more reactive than zinc. Therefore, I would expect this reaction to work. So my magnesium will displace zinc from the sulfate, and that will lead to the formation of magnesium sulfate, and zinc is going to be displaced. Let's put in some formulas. So zinc sulfate is ZnSO4, magnesium is MgSO4, magnesium sulfate, and the zinc is here. Okay, what I find is helpful, I'm just going to grab a sheet of paper. What I find is helpful here is to take an extra line, and I'm just going to split this into its parts, the ions that make this up. So I've got Zn 2 plus, and zinc is SO4 2 minus, and that's then going to go to Mg 2 plus and SO4 2 minus, and then the zinc. Okay, and what I'm looking for now is any ions that I can remove because they haven't changed. They're the spectator ions. So let's have a quick look through, and I can see that my magnesium has become a 2 plus ion, so that's changed. Zinc is a 2 plus ion here, but then it's become zinc with no charge. Sulfate are SO4 2 minus, they're the same. So I'm going to get rid of those. They're my spectator ions. And then that leaves me, if I come back to here, to my ionic equation would become Mg Zn 2 plus, Mg 2 plus, and Zn. Okay, I'll get rid of that for a minute now. So what I now need to do is to write down which of these equations it is, which of these changes is oxidation, which of these is reduction. If I just look at this, I'm going to use a different colour pen for a minute. If I just look at this separately, so my magnesium is doing this, and my zinc is doing this. Okay, let's look at the zinc first. Zinc has gone from a 2 plus ion to the element with no charge. So a positive ion becoming no charge, neutral. I'm having to add negatives to this, so it's gaining electrons. If you remember the oil rig, this reaction here is reduction. The magnesium has become a positive ion. How do you become positive? Become positive by losing electrons. So this is oxidation. Okay, so reduction half equation. I'm looking at my zinc to represent this. So I've started off with Zn2 plus. Reduction is gaining, so that's going to pick up 2 plus means it needs to pick up 2 negative electrons to form zinc. And my magnesium for the oxidation half equation is Mg, and magnesium is going to undergo oxidation to form this. So undergoing oxidation means it's going to lose electrons, so it's going to form Mg2 plus, and it will release 2 electrons during that process. Okay, so those are my two equations for the reduction and oxidation. Have a check, make sure you get them right. This is very similar to the ideas that we've approached in electrolysis in terms of adding, taking away electrons, oxidation and reduction. Good luck.